Hey everyone, in this video we'll learn all about piecewise functions. So a piecewise function is just a function that has more than one formula depending on what the domain is. So let's just write down a normal function, f of x equals x plus 1. So this is an example of one of the normal functions we've been learning about. We can figure out f of 2, f of negative 1, we can figure out f of anything, because f of 2 would be 2 plus 1, which is 3, and f of negative 1 would be negative 1 plus 1, which is 0. We can figure out f of anything because no matter what x value we use as our input, we will always use this formula, x plus 1. So this is an example of a function that's not a piecewise function, just a normal function. Now, how a piecewise function works is the formula actually changes depending on what our input number is. So let's write down an example of a piecewise function. We'll have f of x equals, and we'll open up the curly brackets. So it will equal x plus 1 only if x is greater than or equal to 0. And then it will equal x minus 1 only if x is less than 0. Okay, so now let's try to evaluate this piecewise function at certain inputs. Let's try to find f of 2 for this piecewise function. So f of 2, okay. If I want to evaluate f of 2, my very first step is I have to decide which formula to use. Am I going to use x plus 1? Or x minus 1. And that depends on where the domain falls. Is x greater than or equal to 0, or is x less than 0? Well, I'm picking 2 for my input, and I know that 2 is greater than 0. So it's greater than or equal to 0. So it fulfills this first equation, or this first formula's requirements right here. So I'm going to choose this one, x plus 1. So x plus 1, and then f of 2 would be 2 plus 1, which is 3. So there we go, f of 2 equals 3. Great, so now let's try to find f of negative 5. So f of negative 5, again, our first step is to find out which formula to use. Are we going to use x plus 1 or x minus 1? So that depends. Where does negative 5 fall? Well, negative 5 falls below 0. X is less than 0. So since negative 5 is less than 0, we're going to use this formula right here, x minus 1. So we're going to use x minus 1, and we'll evaluate f of negative 5, x minus 1, so negative 5 minus 1. And what's negative 5 minus 1? That is negative 6. There we go. F of negative 5 equals negative 6. And that's how we evaluate this piecewise function at certain inputs. So now let's go ahead and let's learn how to graph this piecewise function together. So let me erase this. And then we'll go ahead and draw our y and x axes, our x and y axes. So let's draw our y-axis right here, and then our x-axis right here. 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4, 1, 2, make this a little larger so we can fit 3 and 4 in there. Negative 1, negative 2, negative 3, negative 4. Okay, great. So how do we graph this function f of x? So what we're going to do is we're going to graph the first part first, x plus 1. But we're only going to graph it on a certain portion of this graph. we will only graph x plus 1 where x is greater than or equal to 0. So where is x greater than or equal to 0? Well, it's this side of the x-axis, including 0. So from where x equals 0 and all the way to the right to infinity, that is where we'll graph the first formula, x plus 1. So f of x equals x plus 1. That is simply just a linear equation, and we'll go ahead and draw it in blue, where the y-intercept is 1, and the slope is also 1. So it goes up 1 over 1, up 1 over 1, up 1 over 1. There we go. So let's go ahead and connect those points and draw that line. And there, notice we're not drawing the line on the other side as well, because we're not supposed to draw x plus 1 for these negative x values. Because for the negative x values, where x is less than 0, so the negative numbers, so these negative numbers right here, we are going to draw the formula x minus 1. We're going to go ahead and graph x minus 1, f of x equals x minus 1 for the negative values. So f of x equals x minus 1, let's go ahead and graph that. So negative 1 on the y-intercept, but we're going to go ahead and leave that circle open because we're not including x is 0. That's very important. X right here, it has to be less than 0. There is no equal to bar right here. So because there's no equal to bar, it has to be only negative numbers, not including 0. So we'll just show that open circle just as a point for us to start drawing the rest of the graph, but we can't actually close that circle because we're not including 0. And the next thing we'll do, we'll go ahead and draw the line x minus 1. So it has a slope of 1, but remember, we're going backwards. We can't go forwards. We can't go 1 up, 1 over, 1 up, 1 over. We can't do that because we can't use the positive x values. So we have to go backwards to back into the negative x values. So to go backwards, we will go left 1 and then down 1. So left 1, down 1, left 1, down 1, left 1, down 1, or down 1, left 1. There we go. Let's go ahead and connect those points. And there we go. This orange line and this blue line together, they both compose this piecewise function. F of x equals x plus 1 for values where the input is greater than or equal to 0. And it also equals x minus 1 where the input is less than 0. And that's how you graph it. So this is how you graph a piecewise function. And we learned how to evaluate piecewise function at certain inputs. And that's all you need to learn about piecewise functions. So if you guys have any questions, please leave them down in the comments below. I hope this video helps, and thank you for watching.